Okay, so for this video, I'm going to be going over minimum window substring. As you can see, I've attempted this problem before, but it was a while ago when I was not able to solve this problem. This is based off the grokking the coding interview problem challenge for word concatenation, and I will be attempting to solve it. This video might be a bit longer than my previous videos because this is a hard question and I'm a solidly intermediate Leetcoder. So we will see how this goes, and if I'm not able to solve it, then at least I'll learn something, and I'll put whether or not I have solved this question in the description of the video so you don't have to waste your time. Okay, so let me read the problem. Okay, well, the first thing I could do is obviously compare the length of the strings and return false just to handle that edge case right away and guarantee that every string that we see, T can fit into S, because it looks like that we'll have, yeah, this is always going to be a substring if there is one that exists in this larger string. Okay, now let me walk through an example so I can kind of get an idea of how I might be able to solve this. Again, I'm using SkyDraw. I find it's really helpful for working with problems such as this. Being able to drawing out is very nice. Okay. I'll just start with the input string and see how I might iterate through the input string. This is a sliding window problem because we are working through the sliding window problems on grokking the coding interview. And then our substring is ABC. Actually, I'll put it up here. One thing to note is that every character also includes duplicates. It's not that we've seen exactly one of every character, it's that we've seen an equal to or greater amount in each of each character in T. So how I was doing this is keep a sliding window, and again we'll continue to iterate or increase our sliding window until we have an equal or greater than number of each character in our sliding window. So right now we have A. I will put our result here. And then our current sliding window will have something like that. Okay. we see nothing so far, no new characters that exist in T, so we just keep increasing our sliding window. Still nothing. And once we reach B, we see B is a character in our substring. So therefore we increment B. However, these two strings, this string does not have strictly greater than or equal to the number of characters here for each character here. C is still missing, so we continue. And then we finally encounter our first string, or our first match, which is a Dobek. This has, we'll store this in our result for now. And how should I handle the left side of my sliding window once I encounter? Yeah, I think I shouldn't decrease this left side of the sliding window until I reach another character A such that A let's see. Yeah, so I shouldn't decrease the sliding window until I reach this A, because we won't have a valid substring until I have that A reached. So I'll keep increasing my sliding window here and then seeing how the algorithm might work. 0 or O, not part of any of these strings. D, not part of any of these strings. E, not a part of any of these strings. And then we reach B again, which is a part of our string. So this is now 2. But we can't do anything with our sliding window, because if we were to remove the left side, we would no longer have a valid substring. So we reach A. And now, once we have reached A, we can start decrementing the left side of our sliding window. Okay, so I'm just going to erase the sliding window and pretend we have a new one. So this is our sliding window. We see that we could still keep decreasing because there's still a valid substring, and if we were to decrease this left side, none of these components would change. This is at 1 right now, by the way. And yes, so we can continue. Oops, I'll keep that at 1. Again, nothing on the left side. We continue. B. Now we're encountering a B, and we could ask ourselves whether or not to include this or to keep going or not. We see that we obviously can, because we have another B, and the amount of B's that we have is greater than the amount of B's in our substring. So we should be able to safely remove this B. So it's just 1. And then we continue until we can't continue anymore. So E, we could safely remove this E because it's not part of our substring. C, and then we finally reach another potential candidate for one of our substrings. So we have this word, which is 6 characters, and we have this word, which is also 6 characters. I'll just append this right now, but I think when we're coding this, we will do a comparison and only replace the result if the result is or if this new word is less than, at least in terms of length, the number of characters in our previous result. Okay, so let's continue the algorithm. We reach N, and now we reach C. And C, we can also begin this process of shifting our left side. Because we have two of them now. Yeah, so we have two of them now. Our starting window's here. So we can start to decrement our starting window again. And now we have the same amount of characters, or greater than the amount of characters that are in the starting window, so we continue until we can't continue anymore. So we can remove this O. Oops. Now our starting window is here. We can remove this D. We could remove this E. And then now we're at B. And if we try to remove B and set it to 0, we will no longer have an equal to or greater amount in our sliding window. So this is our new result. And this is what we have in our example. So let's try and code this up now. Okay, so we will need a few things, and I think I liked having this substring car set. And this is just to check if a given character is in this substring over here. It makes comparison later easier. What else do I need? I need to have a count of each character. And there are several ways of doing this. Either a hash map or an array. The access for each should be similar. I'm going to do a hash map. Last time I did an array, and these problems are fit well with an array, but hash maps should also be fine. But the size of the array and the size of the hash map are both bounded by the total number of uppercase and lowercase English letters, which is 52. So the space complexity for that should be constant, and there shouldn't be that much of a difference. I just find that the hash map might be a bit easier to read. So I think there's a Python class which does this for me, but this is fine also. Okay, this is just creates a substring map, and for each character, we either have it's a map from the character to the number of occurrences in this string over here. I'll just annotate that so I don't forget. Oh, I forgot to start the timer. It has been around 14 minutes already, so long video. I apologize in advance. What else? We need to have a left pointer which will mark the start of our substring. And we also need to have a result. Yeah, okay. I think this is okay for now. Okay, let's begin. Cur letter is equal to SR. Okay. So we need to do a few things here. Check if current letter is in the substring. If it's not, do keep increasing the R pointer. Continue. If it is, check to see if we also need cur map with charMap is equal to cars. Okay, so yeah, I just included this because we'll need a way to see what values are in our sliding window. Previously, I think it was in either anagrams or permutations, I used a trick where I had a variable which was the count of the number of characters within this charMap, like the number of occurrences total. But this might not work in the case because our substring can have multiple of the same letters. For example, this could have B, A, and C, and this would still be the shortest string, and it would be a valid substring. So a counter wouldn't work in this case. Yeah, I'm a bit slow, but this process requires, or this problem requires a lot of thought from me. If our think it's this left until right. Is it left until right minus +1? This could be the case. Hold on. 0, 1, 2, 3, 4, 5, and we want our substring to be s from 0 to 6. So yeah, it is arm +1. Because we want to include this letter, and by default, this range is non-inclusive. Yeah. Okay, so this is my pseudocode. I'm checking if the letter is in the substring. If per letter in substring cars, let's not continue. You mark it in our charMap. charMap C. Plus equals 1, but we need to change the case in case this is the first time we've seen C. We can't do plus equals if this has not been initialized before. So we'll do charMap get C0, charMap C plus equals 1. What this does is the first value in C, or the first value in get, is equivalent to saying charMap C. But if that doesn't exist, then we get the second parameter by default, so a 0. We just want to increment that by 1. Okay, so we have marked it in charMap now. Okay, so now we need a way to figure out if our current starting window contains all characters of the substring. I might make a new method for that called like def contains all. Okay. And we want charMap self charMap substringMap. For C val and substring map dot items. If C not in charMap, return false. Otherwise, if charMap C contains less than the amount of substringMap C, I guess I don't really need this value then. I mean, turn false. Otherwise, return true. Yeah, so what this does, it enumerates through this substringMap. It checks or iterates through the substringMap, and it checks if first if this character exists in the character map, because it must if we have a matching substring. Otherwise, it checks to see if the occurrences of this character in our character map are less than value, because we can have a greater than or equal to in our substring, but we can't have a less than the amount of in this t. I think I'm confusing terminology a bit, but I hope you understand what I'm talking about. Okay. So now, if self contains all charMap substringMap, so if SL in substring cars. Man, I guess I don't really need substring cars at all, because I can just do the same logic but in this substring map. Yeah, I don't need substring cars substring map. Substring map. Okay. So if the character at the left pointer is in their substring map, okay, remove from charMap increment by 1, check. If check fails, reverse the above operations. Yeah, I think this is fine. So what we're going to do is we're going to remove this value from our current sliding window and increment L by 1. Then we're going to run this contains all method again, see if it still works. If it doesn't, then actually, yeah, I could just move this L out here. So yeah, we're going to run this contains all method again and see if we can still form a substring. If we can't, then what do we do? If we can't form a valid substring still, yeah, we reverse operations. So we add the character back into the character map. Then we I'm just going to ignore L for now. I'll work with L in a second. Okay, so first, charMap SL minus equals 1. If self contains all still of charMap. This is a horrible runtime complexity, and I think there's a better way to do this. I'll look at the solution afterwards, but this is the best way I can come up with at the moment, so. Oh, wait, I don't know if I need to check if the entire substring still works. I just need to check if this individual letter is still greater than or equal to. Okay, so hold on. If charMap SL is greater than or equal to substring map SL, okay, then it's still valid. Okay, since it's still valid, what do we do? I think we just continue. So I think we just handle the not valid case. I could refactor this a little bit. In fact, I will. So I'm doing this just so it's still valid. L plus equals 1. Else. So this is when we can no longer I need to change something to a while loop because this is only going to go off once. So if current letter is in substring map, yeah. I might just change this to a while loop, man. But, okay. I'll just do this for now. And no, do I? Where do I want to put this while loop? So right here we're taking the characters into substring. I think it's underneath here. So well, I'll just put this in a true while loop for now. True. So, okay, so if charMap, yeah, I'm doing this while loop, otherwise we just increment the left pointer once. From charMap, unless we do not remove from charMap. So if the check fails and charMap -1 of this character yeah, so res.append I'm just doing a res out of pen for now. I think it'd be more accurate. Actually, I'll just do that. I think I could do this. I don't know if this copy method works. But res is equal to a string of here. No, you know what? This might be a bit better. If else, if res else yeah, so we're incrementing the left pointer regardless of if the current string is in our substring map or not. So I'm refactoring it so the L is out here outside of this if statement. Okay. If res, so L to R plus 1 else. I think this is a bit more accurate. L can be at R, but I mean, I think so. Okay. But it's better than true. It gives at least a stopping point. Okay. Well, if res length res 0 sub okay, now, do I need to do anything else? I think... So let me just run through this real quick. Current letter, check if the current letter is in the substring. Yeah, mark it in the substring map if it is. If the character map and the substring map, or if the character map contains all the characters and the occurrences of all the characters in the substring map, then we are going to loop. Oh, I need to break somewhere. Okay. If SL is in substring map, if SL is in substring map, then remove from the charMap. Yeah. So this case, we can still continue going because we can successfully remove a character from our window, and we still have a number or greater than or equal to the number of letters in our substring. We saw that with the case, I think it was once you reached this A, this whole thing was our substring. But so we started decrementing, and then we encountered another B, which is in our T string. But because we have more than one B, we could safely remove this B over here. And that's what this check does. The else case, we're going to need a break after the end of this else, because yeah, we need to break because we are appending a new string to a result. If we were to go left anymore, our result would no longer contain the number of necessary characters. Okay, return res 0. I'm crossing my fingers. Next out of range. Okay. Return res 0 if return 0 if res else empty string. Yeah, okay. Okay, so there's something wrong here, obviously. We have no strings at all. I'm going to submit to see how many test cases. We're passing some. Okay, let's run again. And then let's run through our example one more time. Okay. So current letter is equal to SR. If current letter is in substringMap, we increment that map. Okay, I'm going to draw out this while I I'm going to draw this out while I work through the problem. So we have A, we have charMap, and then substring map. And this contains A of 1, B of 1, and then C of 1. charMap right now contains A of 1. So A, yeah. If self contains all, this should return false. Yeah. Otherwise, let's continue with D. Okay, nothing. Her letter, yeah, D. Okay, nothing happens because, again, it's not a character that we care about. O, nothing happens. Again, not a character we care about. B, it is a character we care about. If character letter is in substringMap, charMap.get. Cur letter. If this is a bug, I'm going to be a bit upset. Okay, it's not the bug, but it is a bug that we had to fix. Why was it letting me run with C earlier? For cur letter. if cur letter is in substringMap. Okay. Okay, so continuing on. Now B is 1 if charMap continuing on, E, nothing, C. C, we do definitely have something. So F, if charMap of SL minus 1 is greater than or equal to substringMap SL, in this case, charMap of SL refers to A of 1. Yeah, so I noticed that, oh wait, no, never mind, this does work. So if okay, so we can do that. So we're in our else branch. New sub is equal to L5, 0 to 5 plus 1 is 6, which is the string. Okay, that should be fine. If result is currently nothing. Else result dot append new subsequence. New subsequence is our original string, and then we break of this while loop. This for loop should continue though. If res return okay, so I wasn't able to immediately spot the bug in my program. Obviously, our output, we're not appending anything to our output. I'm just starting to get a little bit stumped. I might run the debugger just to make sure that I'm not missing something obvious. So I might look at this one more time. charMap, charMap, substringMap, charMap, substringMap. We enumerate through the substringMap. If the character is not in the substringMap, if the character that is in substringMap is not in charMap, then return false. I might try this just for sanity. SubstringMap. Yeah, no, okay, that didn't make a difference, but Okay, I'm running through the debugger. I feel like I'm missing something kind of simple. Oh my gosh. Okay, well, we got it. First try, I guess, except for this bug, which was very stupid. But as you can see, we've gone this wrong a few times before. I'll just show you real quick what that looked like in the past because it was horrible. Oh my gosh. Well, sometimes the most frustrating bugs could be the simplest. Oh, I can't believe I didn't catch this. It was right off the start, too. Okay, well, thank you for sticking around this long if you did stick around this long. And if you want to see any problem on Leetcode solved by an intermediate Leetcoder, please comment below. Otherwise, thank you for watching, and I will see you next video.